Hello guys, welcome back. If you are watching this video, then after watching this video, after finishing this video, at the end, what are the concepts that you will get? What knowledge that you will get? In this lab, we are taking and loading some data. That is Boston housing data we are taking. It is available in Google. You can see this is the GitHub page related. Directly Kaggle related data set is there. You just search for this Boston.csv. Then you will get a Kaggle related data set as well as a GitHub related data set also available. You just click on, you just open any one and you can download that data set. Currently, I downloaded one of the data set from these two. I'm taking that Boston data. Then I will load that data. Then after loading that data, I want to visualize this data, how the data is distributed. Then after visualizing this data, after seeing where actually the data is distributed, like how much values are there, then to make calculations easy or to train my model easily, I want to normalize my data. To do this, I'm using standard scalar method. I'm using. Then after standardizing my data, I want to create a regression model, that is to predict the output. By using this data set to predict the output, I want a model. Since we are predicting the output, that is it does not come under the classification. Since our current need related to prediction, we are using some regression based model, that is Ridge model that I'm using. And we will also identify the performance. Now let's have a question. If we want to identify the performance of a regression based model, regression based ML models, then what are the metrics that you have? So the answer for this is, if you want to evaluate the performance, if you want to identify the metrics of regression based models, not classification based models, regression based models, for regression based models to identify the performance or metrics, you need to prefer R2 score, or you need to prefer mean squared error. So these are the metrics that we actually prefer to identify the performance of any regression based models. Let's say if you are identifying the performance of classification based models, during that time you need to prefer accuracy, precision, and you also have that matrix, confusion matrix, ROC, those kind of things we need to prefer. But now we are preferring this R2 score to identify the performance metrics. Then after, we are expecting to improve the performance. For that, we are not taking this model, we are creating one more pipeline. Then we are taking the help of CV. So what does the CV means? Cross validation. By using GridSearchCV, we are identifying, or we are taking the best value based on the alpha. For this Ridge model, we need to set the alpha value such that the performance may improve for our data set or for the future prediction purpose. So that we will validate and identify under this GridSearchCV, and we will, after creating this model, we'll also identify the performance metrics and we'll observe the improvement in the performance score. So in short, we are taking this Boston data and we are visualizing that data. Then after, we are normalizing this Boston data by using this standard scalar. Then we'll create our model, that is a Ridge model, or we will train our model and we'll identify the score for predicting the output. Then after, to improve this performance, we are considering this GridSearchCV. Okay, so this is all what we are doing in this lab. Now you can see this is the platform that I opened, that is this Jupyter notebook. Here first I want to load the dataset. So I'm importing pandas to load the dataset. To load the CSV file, I'm using this read CSV, and we are providing the path where I actually store that Boston data. Then I'm storing the data in this D variable. Then finally I'm printing this, so that to see how many rows I have in the data and how many columns I have. So totally 506 rows or records, 14 features or columns I have in this data set. Now I want to visualize this data, like at where my distributions, like in age, in between what values my data is present. So to see that, to visualize that, I want to import Seaborn. I'm importing the Seaborn, and I want to visualize this data by using box plot. So I'm using that box plot, and here I need to specify which data I want to visualize. That data set I need to specify. This D data I need to visualize. So that's why I provided D, comma, the data I need to provide in data. PD dot melt that D data and use that as a data to visualize. I'm just running this. Shift and enter. I'm just pressing. You can see from here till here the data will be, or from here till here, and from here till here, from here till here. So the overall data resides, or the overall data will be in between this data set only, like this range only. I want to see separately. I don't want the overall data related. I want each and every column related. So for that, I'm just providing, currently values are under X category. I want to make it as Y category. Y is nothing but my value and X is nothing but my variables. And now you can observe, still there will be a merge, or I cannot able to see all the columns, right? Correctly, I cannot able to see all the columns. I want to adjust this figure size. If you want to adjust the figure size, you need to import matplotlib.pyplot. I'm importing this as PLT, and I'm setting the plot sub subplots size, subplots figure size I'm setting. That is, I want to increase the width, right? Yes. I'm just taking the height as 5 and width as 10. Let's rerun this. For that, I'm clicking shift and enter. I think so. The first one is related to width, I think, and the second one is related to height. I want to just adjust this 10 comma 5 and rerun this. Yes, now I can able to see all the values, right? Yes. Now this CRIM values are present in between 0 to 100, and ZN values are present in between slightly above 100, 0 to 100. Yeah, like that my data, how the data will be distributed, that is clearly visible for each and every column, right? Yes, I can able to observe the data is distributed from 0 to 700. Now, in order to train my model, train my regression based model, here the problem I want to solve is by using all these data, by using all these rows except MEDV. Consider the Y value will be D of, in my data I want to take MEDV as the output value, and all the other values except MEDV, like D dot drop that only column, that is MEDV, and consider all the other columns, drop this axis, that is 1. If I drop this, then this data will be dropped. And if I mention this column, then this only column will be dropped and this only axis will be dropped now, since I mentioned only those two. Now other things, that is all the other columns will be considered as the input, and for the output I have already taken a Y variable and I'm taking this data. I'm just running this by shift and enter. So now, yeah, this got run successfully. If you observe the X, I'm just shift and entering it. Okay, so except that MEDV, all the other columns will be taken. And if you see the Y, yes, we can able to see that the output, right? Yes, we can able to see these output values. Now based on this input, I want to predict this output. Since it's not related to classification among one category or among two categories or multiple categories, since we are predicting the output, we need to consider this type of problem as regression based problem. If we are predicting the output, not classifying the output, we are predicting the output. Based on this input data set, we are predicting this output, not classifying. So it belongs to regression based problem. To solve this problem, I am expecting to use Ridge model. I want to use Ridge model. Before training or before using this input and output data to train my model, first I need to split this data set into training and testing purpose. For that, I have this sklearn.model selection. In this, I want to import one train, test, split. In this method, this method will actually provide me the facility to split the data set into training and testing. Train, test, split. By using this function, by passing the inputs like input values like X and output that I want to use, that is Y, and providing the test size, that is 20%, let's consider, that is 0.2. This input values and output values are split into two parts. One is test data and another one is training data. Based on here how much you provide, based on that 20% of the data in this X values and Y values are taken for testing purpose, testing data, and the remaining data will be 80% will be taken for training. Like that it will split X underscore train, and it will provide you two things for both X and Y, that is training value as well as testing value. So I'm storing them in the same, right? I'm storing in the X train, this X trained data, and X test, that X test data. Like that I'm storing. I just want to see whether the length, like okay, the length of the number of records which are distributed. You can see totally 404 records are present in Y train in training data set, and in the test data set, the remaining like 1 or 2 records are distributed. That is, whatever the testing Y data, output data that I have, that is split into two parts. One is for training and one is for testing. 20% of data is considered for testing, and the remaining percent, 80%, is considered for training. Like that, we implemented this train test split on this data set by providing this test size. Okay. Now, before using this X and Y values for training our model, we need to normalize this data, because if you observe, the data will be present in between 0 to 700, right? Yes, the data will be currently present in between 0 to 700 values. If on an average, if we consider 400 as the value that we are taking for calculation purpose, it might take, since a large value, calculation will take a lot of time. If we decrease the data, if we decrease the data size, then what happens is the processing or calculations becomes easy, and we will get the output very fastly. So I want to normalize this data set. Whatever the input data set that I have, that I want to normalize this. First, I want to normalize the training data set. Before training my model, I want to normalize the training data set. To normalize this data set, as mentioned before, we are using standard scalar. So from where I need to import that? From sklearn dot pre-processing. I need to import that standard scalar, and I'm just creating a scalar by using that standard scalar. Now I want to create the scale data from this trained data set. Whatever the extrained data set I have, from that I want to create a scale data. For that, what I'm doing, by using this scalar dot fit transform, I'm using this extrained data to create this scaled trained data. I'm just expecting to print this scaled trained data after creating this. Okay, to see how the data will be, you can observe the data will be numpy array. I want to see this data as a data frame, like x scaled train data in the form of data frame. I want to see this, and then I want to print that x scaled train data frame. How to convert this into data frame? To convert this into data frame, we need to use the pandas. I previously imported this pandas as PD, so I'm using PD dot data frame to convert this numpy array into data frame. You can see I just shift and enter, I just pressed. You can see it was converted to the data frame. You can observe the data will be normalized. So can you show the same figure, like this figure? I want to visualize in this manner so that it will be easy for me, like how the data will be, like in between what variables the data will be present. Okay. So to see that, let's import again that cborn import, or once we import, that's okay. We don't need to import that cborn again and again. We just need to use that cborn dot plot. So what we are expecting to plot, which data we are expecting to plot, pd dot melt of this x scaled train data frame, scaled train data frame. I am plotting this, and for the y, I need to consider the value as y and the variable as x, so that I can able to visualize the data. If I just click on shift and enter, okay, box plot it is not a normal plot. Here you can see the data will be clearly normalized. So all the data will be now actually present in between. You can observe -2 to, can I say 4? Yes. So in between this only my data is there, right? Yes. We can say now our data is actually normalized, and almost it is equivalent, like the data will be equivalent. The data points are equivalent for each and every data set. You might still have a question in your mind that how this standard scalar normalizing the provided data. This standard scalar depends on mean as well as standard deviation. Based on these two data of each and every row, the each and every record or each and every value will be further scaled by using this mean and standard deviation, like it may be divided internally so that the whole distribution do not disturb. Like that, it will consider and do the standard deviation based on all records related mean, standard deviation, and it will normalize the data of each and every row, and that data we are considering, so that the final mean or standard deviation won't be changed for the row. For each and every row, the same thing happened. Mean and standard deviation will be identified based on those two. Each and every column related item. So this column, in this column, the first item will be scaled or normalized based on these two values, based on these two data of whole column. So that's why if we consider this feature related data, or this feature related final mean or standard deviation or statistics, that won't be changed even after normalizing this data. If we do this normalization, what is the benefit, sir? The processing will be faster while training, and the calculation and approximations will be faster. You can see all the data sets are present in between approximately -2 to 2. In clear, if we observe, then it will be 1 to -1. So let's expand this by using plot dot subplots of figure size. I want to put it like again 5 and 10. So to see this, I think I need to put in reverse way 10 comma 5. Yeah, it's a bit expanded. Okay, so totally 12 columns are there, and yeah, in between now we can able to observe a bit. Yes, so that's how the distribution will be, or normalized data will be. Before normalizing, you can observe the data how it will be, right? After normalizing, how the data will be. Even after normalization also, the performance won't be changed, or the whole column related mean standard deviation won't be changed, because based on that only the normalization we have done right now by using this standard scalar method. Okay, we normalized the data set. Now I want to train a model to perform this prediction, or to perform the prediction of output value. I want to train a regression based model. For that, I'm using a ridge model from sklearn.linear model. I want to import this ridge model, and so I'm storing that model in this R variable, and then I want to train this model. So r dot fit method I'm using by using the training data. So what is my training data? X train and y train. After normalizing, what is my x training data? This, right? X scaled train data frame. I'm just copying that and taking that as x value, and y underscore train is the expected output for these input. So that also I'm taking, and I'm just clicking on shift and enter so that this will be trained. After training, I want to see the performance. How to see the performance? You need to import sklearn.matrix. From this sklearn.matrix, you need to import this R2 score. As we mentioned, you can use this R2 score, or you can also use mean square error. So this also you can able to use for identifying or for evaluating regression based models. Currently I'm considering only this R2 underscore score. I'm taking this R2 score and passing the data like y predicted. For this data, for this model, for this trained model, I'm using predict method and passing the input like x underscore test data to predict the y output. I want to predict the output. So to predict the output, I'm using this R model or ridge model to predict the output. And for this exit test data also, I want to pass scaled test data. Scaled test data frame itself I want to pass, because while training itself I am passed the scaled or normalized training data I provided. In the similar way here also I want to predict the result of this test data by passing the normalized value only. So x underscore scaled test data frame. How do I get it? To get this, so first we need to normalize the data, right? After that we need to convert the data. First x scaled test data I need to get. For the x test data, how do I get scale test data? So very simple, you can just use that scalar dot transform method so that you will get the scale test data. After getting the data, if you want to convert that into data frame, pd dot data frame, capital frame, data frame of this x, I need to mention here also capital, x scale data. So this x scaled test data, I'm converting it into first taking the test data, and then by using the scalar dot transform, I'm converting it into scale data. X test data I convert into scale test data, and I'm taking that scale test data and converting it into data frame by using this code. Then after I'm predicting the output for that data, and I want to use that y predicted as well as test, y predicted test versus y test. What is the gap between them, or how the performance of our model will be? If I get R2 score will be more, then I can say the performance is better. You can see here 0.769 I got, right? So this is the model performance I got. I want to improve this model performance. To improve this model performance, as per we said, I want to use this grid search CV. To use this, first we need to create a pipeline. So let's create a pipeline and then implement this grid search CV. So instead of implementing this grid search CV on this R value or on this already available model, I'm creating one more model and I'm implementing this grid search. So to implement this, so first let's create a pipeline. To create a pipeline, we need to import the pipeline. sklearn.pipeline. From this, I'm importing pipeline and I'm creating a model by using this pipeline. Since it's a regression based model, I'm providing R underscore model. So just to remember, I provided name like this, but in real time, you might put the name like however you want. Here I want to provide two things. One is scalar, that is normalization I want to do. So that scalar I providing here, that is a standard scalar. And then after normalizing my data, I want to send the data to particular model, that is Ridge model. So that's why I'm providing this Ridge model here. So whenever I send my data to this pipeline, so first that data will be normalized, then after it will be sent to the model and we'll get the predicted output. Then now we created a pipeline, right? Yes, our pipeline got just now successfully created. If we run this, then our pipeline will be created. I just print this R underscore model. You can see the pipeline got created with this data. So whatever the data that we provided, based on that, pipeline got created. Now to make this model to be a bit better performance, to provide a bit better performance by assigning alpha value automatically, I want to use this grid search CV method. This grid search CV method. So where actually this grid search CV method is present, sir? This also present in sklearn dot model selection. So here actually this grid search CV method is present. I want to use this method and I want to create a model, or I want to create a CV. So what does CV means? So in my words, CV represents cross validation. Let's say I have a data set, like let's say I have 10 records, and if I provide CV value as 2, then this 10 records will be cut into two halves. So one half is 5 and the another half is 5. So that will be considered for the first time for validation. This will be taken, this first five records, this first 5 records will be considered for training for the first time, and these 5 records were considered as testing for the first time. After the first iteration, second time, these 5 records will be considered for training and these 5 records will be considered for testing. So based on that data, based on that results, this grid search will automatically adjust parameters. For this model we have alpha, for another model we might have some other parameters. Those weights will be automatically adjusted by using this grid search CV method based on the cross validation. So let's say currently I divided this 10 into 2 records. Let's say I have 12 records and I want to do cross validation by dividing the data into 3 halves, 3 parts. So that is cross validation is 3. Then this 12 is equally divided into 3 halves, like 3 fourths are 12. So 4 comma 4 comma 4. So for the first time, this 4 plus 4, 8 records will be considered, or first time this 4 records will be considered for training and the other records will be considered for the, that is other 8 records were considered to be testing. Then based on the data, the model will be identify some results like weights or whatever the data that it will get. Then after, during the second iteration, these two will be considered and the other value will be considered for testing. So this will be considered for training, these records will be considered for testing. So in the third iteration, only this data will be considered for training and the other two, like this 4 and this 4, are considered for the testing. So in the next time, this, like these two will be considered for training and the other 4 records will be considered for testing. So in the similar way, lastly, this 4 records will be considered for training and this combo of 8 records will be considered for testing. So at last, I think one combination left, that is this 4 plus this 4. So those two will be taken as a training and this will be considered for testing. So like that, all possible cross validations will be taken for training and testing, and this grid search CV will identify the parameters exactly, like what weights or parameters will be considered so that the model will perform much better. So that value will be considered and that will be used so that the model performance will be improvised. So now we are using this grid search method to identify the parameter to improvise the performance. Okay, now I'm just using this grid search CV method and I'm just providing to what model I'm applying this, to this R model, to this R model pipeline that we just previously created, and we are providing cross validations to be 10, and we also providing the grid parameters, that is PARAM, parameters GRID. So parameters of our grid are the alpha value that we need to provide the parameters of our grid model related alpha. We need to provide here, that is a model related alpha. I'm providing this model alpha value. Currently for this demo, I want to take equally distributed 10 values. So in order to generate that equally distributed 10 values, I'm importing this numpy and providing that numpy, like, so numpy, I'm using that numpy library to generate log space of values, like 10 values I want to generate. In between 10 power minus 3 to plus 3, 10 power plus 3 to 10 power minus 3, I want to generate exactly 10 values. So that's why I'm providing code like this. And now I'm just running this so that it will just create me this algorithm with this data. If you run this CV, then you can see all the values that you provide, like a parameters, grid, like model alpha values that you are considering. I'm considering these 10 values with equally spaced. So that's why to create these values, I'm using this numpy. It will create actually 10 values in between 10 power minus 3 to 10 power plus 3. Okay, now I want to fit any one of the alpha value to my model so that to improvise my model, like highest performance model I want to pick. So I just want to use this CV dot fit command to provide the training as well as the testing data. X underscore train I am providing, and Y underscore test also I am providing, and I'm just clicking on it. Sorry, Y underscore train, right? I want to provide. So now the model got trained successfully. Our model was just trained. So if we consider one thing, that is a performance, like R2 score, I want to consider R2 score between the predicted Y value. So Y predicted value. So how do we predict the values of Y? I am just taking the model that is a trained model, that is CV. After this grid search dot. So what I want to do, I want to predict whatever the output for X test data. Then I want to use this Y predicted value, and I also need to pass Y test value to see the R2 score. Now you can see this is the max R2 score which is possible by setting any one of these alpha values. Like by setting any one of the alpha value, this is the maximum R2 score that is possible, that is 0.76 something. Now if we observe the previous one, so the training is there. Yeah, we have seen the normalized data. Yeah, 0.76 some points are there. I'm just copying this. Yes, I'm just pasting that here. So you can observe. So here it is a bit more less. That means the performance will be decreased or increased based on the alpha value that we consider. So this all happened. So this all will be happen based on the alpha value that we consider. Here we just consider the alpha value between 10 power minus 3 to plus 3, and we just considering only 10 values of equally distributed. So that's why we got the performance like this. Like if we take the large value, like if we take the large data set of our alpha values, then we might get a best result, or we might get the best alpha value, and we might get a bit more performance for that particular alpha value after this GridSearchCV implementation, that is cross validation implementation. So in that way, by cross validation, by using this GridSearchCV, we can able to predict alpha value or weight, or so particularly based on the model, we'll identify the weights, and we can use that weights in real time to provide high performance by using that particular model. So that is all about this video. We have understood all these concepts, like we loaded and visualized this boosted data, and we normalized the data by using this standard scalar, and by using this ridge model, we also created a model and taken this data and trained this data, and we identified the performance by using this R2 score. Then after we identified how to identify the performance, or how to pick, or how to identify the model related best parameter. So for this model, we considered the model alpha value, and we identified among 10 values, we identified one of the value, and we set that model, we set that alpha for this particular model, and then finally we also identified the improved performance score. So in real time, you need to implement in this way so that you can able to get the high performance related model for achieving your particular task. So I hope this video is useful and you got the knowledge regarding all these concepts. If you feel this video is really useful, then please like, share, subscribe, and hit the bell icon, and please support us to get more such informative videos. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys.